Hi, welcome to part 2 of the Java Crash Course. In this video we'll be talking all about variables and types. So let's go over what are variables. Variables essentially just store data. You might know what variables are from algebra, like x equals 5 if you've taken algebra. However, in this case, variables can store many types of data. In the example below we see int age equals 23. Try and figure out what this does before we go over it together, and if you can't, that's perfectly okay. Alright, so all we're doing here is making a variable that age should be equal to 23. The int part of it is simply just saying that we want this value to be an integer, which can store whole numbers. We'll go over different types in a bit, but here's what the most bare bones variables can look like. Variables are really essential to the concepts of programming, because let's say you want to store the player's health. We have one main variable declaring that with int health equals 100, then when we want to decrease health from the player, we can just do that from a variable. It's immensely useful for storing data, and it can clean up a lot of arbitrary numbers floating around in your code. Declaring variables. As you can see from the code below, we see type myVariable equals value semicolon. The type is just what type of variable we want it to be, which we'll go over in the next slide. For us, we want to store an integer. So imagine the type is just int, like in the previous slide. Now the cool thing about variables is we can essentially give them whatever name we'd like to give them. It doesn't have to be confined to x, age, health, or anything else. If we really wanted to, we could make the name bananas. Next is the equal sign. This is just the assignment operator and is telling Java we want to assign bananas to something. And finally, the value is just how many or what we want to store. So in our case, maybe it's 3 bananas. If you still don't understand this, don't worry, it's perfectly normal. We'll be going through lots of practice with this together. So what we're going to do is we're going to launch up IntelliJ and go into our project that we had last time. We're going to remove this system.out.println for now, so just delete that. And then here, all we're going to do is define our bananas variable. So like we said, it's going to be int, all lowercase, bananas, all lowercase, is equal to 3. Now take a moment to make sure your code looks exactly like mine, and just remember, case sensitivity matters. And so now we've declared a variable that's a type of integer that stores whole numbers, and we're assigning it to 3. So now, if we really wanted to, we could do system.out.println, and here, instead of putting something like hello world, or whatever we want to put in here, we can remove these parentheses, and we can just put bananas. So then, if we run our file, you'll see 3, because bananas is equal to 3. So if you made bananas equal to 8 and we ran it, you'll see 8. So that's the cool thing about variables. Now let's go over the different types of data. So these are the most primitive types. Int, this is what we just saw. From the example on the right, you can see int age equals to 25. Integers can store whole numbers. So some examples of this could be 15, -7, 28, 25 as you can see there, whatever. The next type we have are doubles. These are almost identical to integers, but they can store decimal points too. You can also hear things like float being tossed around, but double and float is near the same thing, so you shouldn't worry about the difference for now. Again, as you can see from the example on the right, double height is equal to 1.71, and the precision of a double in Java is 10 to the -324th decimal places. Now that's a lot of numbers it can store. Next we have a char. A char is just short for a character, like a character on your keyboard. Instead of putting a number in the value, you can still put any character surrounded in single quotes. So for example, I've stored the letter A, but you can put whatever letter you want as long as it's just one character. For example, M, U, L are all valid characters, as long as it doesn't contain more than one character. Finally, you have a boolean. This is arguably one of the most essential ones. All these do are store true and false, or in binary terms, 0 and 1. So it's essential for many things. For example, you have a boolean saying whether the game is running, a boolean for storing if something is an animal, etc. This is all what computers run on, is booleans essentially. And if you think about it close enough, almost everything in life is a boolean. If you look at a tree, you could think, is tall, is wide, is old, etc., which are all just true and false. So let's go ahead and get some examples with these. Under here we'll put double height is equal to, what's a good banana height, do you think? I think 18 centimeters is good for a banana. Next we have a character, so we're going to store char banana initial is equal to B in single quotes. And the next one we have boolean is fruit is equal to true. Now, we'll go over naming variables in a little bit, but just know it doesn't really matter exactly what you name them at the moment. Just know whenever you're using the variables, for example, system.out.println bananas, it is case sensitive. So if we just copy this down 3 more times, we can put in here height, banana initial, and is true. So if we run this again, you'll see 8 for int bananas, 18.0 for height, B for banana initial, and true for is fruit. But now since height is a double, we can put any decimal value we want in here. For example, 18.241. But if we try to do that with an int, you'll see there's a red underline saying that provided type int provided double because we provided a double value and we wanted to use decimals. We'll see the double height is equal to 18.241. Now, I already hear you saying, characters aren't really all that useful, and you're completely right. Only on very, very rare circumstances will we actually just use characters by themselves. Usually we'll want to make a whole array of characters. Last video, when we printed out hello world, that was actually a string. All the Java virtual machine is doing is taking all the characters in hello world and essentially assigning each character to its own char variable. It's really neat. So from the example below, you'll see we're just assigning the value hello world to a string hello world, and then we're printing it out. You'll see a few differences though. Firstly, we're using double quotes and not single quotes. It's convention to use double quotes for strings and single quotes from characters, but it's not strictly necessary. The next thing you'll obviously see is that the string type starts with an uppercase letter, and it isn't lowercase like the rest of them. Just know this is intentional for now, and this is something we'll cover in depth later as this is a relatively advanced topic. Just know strings start with an uppercase character and everything else is lowercase. Weird, I know. And since println takes in a string, we can use our hello world variable and just pass it into that. So all we can do here is declare a string with an uppercase S, name is equal to banana. So now we can do system.out.println name, and when we run it, you'll see banana 8, 18.241, B, and true. Now another neat thing is that we can reassign variables. So in the example I talked about earlier about the player's health, it always starts at 100, we know that. But what if the player takes damage? What then? Well, we can just reassign the variable. So in this example, we have int age equals 24. We should already know what that does, and then below we're just reassigning that age to 19. So if we want to print out that age or try and access it below where we say age equals 19, we'll get 19 instead of 24. However, you'll see when we reassign it, we aren't declaring the type as int. This is because when you're reassigning it, Java automatically knows that the age is type of int, so we don't have to redeclare it. I know we're doing a lot of jumping and forth between IntelliJ and slides, but just bear with me. So maybe down here, if we wanted to get rid of some bananas, we could just say bananas is equal to 3. And now we just have 3 bananas. So now if we run the current file, you'll see 3 and not 8. Now it's very important to know that you should reassign your variable before you print it out, because if I were to remove this here and place it under where we print the bananas, you'll see that it's still 8, because we're only assigning it down here, and the Java virtual machine runs everything in order. So the order that you put things is very important. Now, with great power comes great responsibility. That great power being able to name your variables anything you want. So here are some good conventions. You should always try your best to follow them. In the example below, we see a good example being string student name equals asnos. This variable name is pretty descriptive. However, if we go to the bad example, you'll see string sn equals asnos. This is short for student name and is easier to type. However, think if you're revisiting this project after 2 years. You're going to have zero clue what sn is, as it's not very descriptive. Another example we see is int age equals 24 and int x equals 24. Again, revisiting this project in 2 years, you'll have no idea what x is even meant to be though. Alright, so now we'll go into conventions. A first word of the variable should always be lowercase, and the second words or any words that start after it should be an uppercase letter. This is called camel case. As you can see, is student equals false, which is starting with a lowercase letter as a first word, and student being capitalized since it's a second word. What you don't want to do is make your variable that has 2 or more words fully lowercase or fully uppercase, as it's not really easy to read. Finally, we see string my name is equal to asnos, and we see string space my name equals asnos. In Java, you can't put spaces in your variable names, so this is why camel case comes in handy. You can easily distinguish multiple words that are all in one variable. So now we know how to name our variables, let's go into constants. So you know how I said a variable shouldn't be fully uppercase? Well, there are some exceptions. Constants. Constants are variables that you know will never ever change. Like for example, pi. We all know pi is always 3.14159. That'll never change unless some revelation in math happens, but I doubt that'll happen anytime soon. So you can declare this variable like normal, but instead of saying double pi, we put final double pi. The final keyword just makes it so the variable cannot be changed, hence it's final. Next, for constants, the whole variable name should be fully uppercase, and if you want to have multiple words in constant names, you have to put an underline. For example, my underscore variable. So let's go ahead and get some practice with this. So, for example, we always know that the string name is always going to be bananas, because I doubt the banana name is ever going to be changed. So here, instead of string name, in front of that we can put final string name. And now if we try to reassign this name, so name is equal to orange, you'll see we get an error because we cannot assign a value to a final variable. And we should also make this an uppercase here, just because it is a constant, and constants are usually uppercase. Now you'll also usually try and put constants at the top of your file or class, so we'll do that just for convention. And now all of our constants are up here, and all of our variables are down here. Now type conversions. Typing conversions can be a bit tricky as it can be an advanced topic, so it's okay if you don't understand these yet. Luckily, most of the time Java will automatically cast our variables for us. For example, int num equals 10. Well, what if something needs this to be as a double value? Well, we can just reassign it to a different type. For example, double decimal equals num. All we're doing is declaring a variable as we have with a different name, and just assigning the value that num has. And now we can just pass that new variable into anything that needs a double value. Now I should be careful with this though. As you can see in the next example, this can get messy. We see our pi constant again, but what if we now want our pi constant to be an integer now? The syntax for this is int whole number is equal to open parentheses int close parentheses pi. Again, we're firstly reassigning the type and making this a new variable so that we can have the integer that we want in our new variable name here. However, this won't work on its own to cast a double to an integer, so we'll have to cast it with the syntax of open parentheses int close parentheses pi. Just be very, very careful when casting doubles to integers, as when you do this, you'll lose all the decimals. So 3.14159 just becomes 3. Alright, now before we end the video, I have a quick challenge for you. Create two variables. One of them should store your age, and the other variable should store your name. You'll then print out both of the variables separately, and go ahead and pause this video, and I really encourage you to try and do this on your own. Alright, so you should have been able to breeze past this. If you have any troubles with it, I can't recommend highly enough to watch the video. We're first declaring two variables. The first one should have been a type of integer. It doesn't matter what you really assigned to this, as long as you made it a whole number. And then the second variable should have been type of string. And again, it doesn't really matter what you put in here as long as it was a string surrounded with double quotes. Then we'll use system.out.println, and then the first one is printing our age, and then the second one is just printing the same thing for the name. Great, so I really hope you were able to complete that. If you have any errors or questions, please leave a comment and I'll try my best to help you. It might also help to rewatch the video again if some concepts aren't very clear. And thanks for watching, please like and subscribe since these videos take countless hours to produce,